You've probably seen the headlines by now. NASA may have found a sign of life on Mars. Tiny, almost invisible spots, yet they've become the biggest space news in over half a century. If these marks truly are biological, it would be the most profound discovery in human history. But we've been fooled before. So, have we finally done it this time? I'm Alex McColgan, and you're watching Astrum. Today, we'll dive into what NASA's Perseverance rover found, why scientists are so excited, and what it will take to finally prove we're not alone in the universe. The mission. In February 2021, NASA's Perseverance rover, Percy as it's affectionately known, landed on the floor of Jezero Crater, an ancient Martian lakebed. Billions of years ago, this was a place of flowing rivers, a landscape where water carved deltas and left behind rich layers of clay and silt. And where there's clay, there was once water, the key ingredient for life. Percy's mission is simple but monumental: to search for ancient microbial life, to collect samples of Martian rock and soil, and to prepare them for an eventual return to Earth. If there's anywhere on Mars that might hold traces of life, Jezero Crater is one of the best places to look.
The discovery: Leopard Spots. In July 2024, while exploring the ancient Neretva Valley's river channel, Perseverance's cameras spotted something unusual: a rock from the Bright Angel Formation, later named Cheyava Falls. Using two of its most advanced instruments, Pixel, the planetary instrument for X-ray lithochemistry, and Sherlock, scanning habitable environments with Raman and luminescence for organics and chemicals, scientists found that the rock was made of sedimentary clay and silt, materials that, on Earth, are excellent at preserving microscopic life. Percy took a closer look, and what it saw was astonishing. The rock was rich in organic compounds: carbon, phosphorus, and iron, arranged in ring-like patterns, tiny dark circles about the size of sand grains, nicknamed leopard spots and poppy seeds. Each spot was between 200 micrometers and 1 millimeter wide, but the implications were enormous. The light centers of these spots matched the chemistry of the surrounding rock, but their darker rims were enriched with iron and phosphorus, a clue to localized iron reduction. And where there's water, organics, and iron reduction on Earth, there's almost always microbial life. Could this be the first genuine biosignature ever found beyond Earth? Alternative explanations. Before jumping to conclusions, the scientists asked the critical question: could anything else explain these features? Two key minerals stood out: vivianite and greigite. On Earth, these minerals often form through microbial activity. Microbes like Geobacter metabolize iron instead of oxygen, a process called chemosynthesis. Their chemical waste, iron 2, reacts with phosphate and water to form vivianite. Similarly, sulfate-reducing microorganisms can create greigite as a byproduct. But what if there were no microbes? Could these reactions happen without life? One hypothesis was high temperatures, volcanic gases leaking into groundwater. But there's no evidence of volcanic or hydrothermal activity near the site. Another idea: perhaps sulfate in the rock reacted with organic material at moderate heat. But the temperatures needed, over 150 degrees Celsius, simply weren't present. Then there's acidity. Highly acidic water could, in theory, cause these kinds of reduction reactions. But that idea fell apart when Perseverance found a nearby green mineral, olivine. Olivine quickly dissolves in acid. If the environment had been acidic, it couldn't have survived. The presence of olivine meant the water here wasn't acidic at all. Every non-biological explanation was ruled out, one by one.
The scientific process. Science is, at its heart, about falsification, testing ideas to destruction, not proving them right. NASA's team set out with a null hypothesis that these patterns formed through non-living processes. After months of careful study, they simply couldn't find any inorganic explanation that fit. That doesn't mean we've proven life, only that nature has forced our hand toward the biological. Still, NASA is cautious. We've been here before. False alarms of the past. In 1976, the Viking landers ran experiments on Martian soil, injecting it with nutrient-rich radioactive compounds. To everyone's shock, they detected gas emissions, a sign that something, maybe microbes, had metabolized the nutrients. Excitement swept the world. But decades later, we discovered that perchlorate in Martian soil had caused a purely chemical reaction, a false positive. Then, in 1996, a Martian meteorite, ALH 84001, appeared to contain fossilized bacteria-like structures. Even President Bill Clinton made a public announcement. But in 2022, the microbes turned out to be mineral artifacts created through a natural rock-water process called serpentinization. False alarm again. So the big question is, will this time be different?
The next step, bringing Mars home. To know for sure, we need to bring the rocks back to Earth. That's the goal of the Mars Sample Return Mission, a monumental 3-part campaign involving NASA and the European Space Agency. Perseverance has already completed the first step, drilling into Chayava Falls and storing a sample named Sapphire Canyon. Next, another spacecraft must land on Mars, collect the samples, launch them into orbit, and deliver them to a third spacecraft for the journey home. It's one of the most complex missions ever designed, with a price tag of around $11 billion. And as of now, the mission has been delayed indefinitely, even though it remains NASA's top scientific priority. If those samples ever make it home, scientists will run the most precise tests imaginable, looking for 2 key fingerprints of life. The first, chirality. Amino acids come in left and right-handed versions. Life on Earth overwhelmingly uses the left-handed kind. If Martian organics show a distinct preference, that could be a major sign of biology. The second, carbon isotopes. Living things on Earth prefer carbon-12 over carbon-13. If the same ratio appears in the Martian rock, it would be another compelling clue. NASA even created a confidence of life detection scale, ranging from level 1, which could be caused by life, to level 7, multiple teams have confirmed life independently. Right now, we're probably sitting around level 3 or 4. To reach level 7, we'd need independent proof and evidence from a completely different site on Mars. What it means for us. Even if this turns out not to be life, it's still an extraordinary discovery. Mars is a time capsule of an ancient Earth. Its crust is frozen in time, untouched by tectonic drift or erosion for billions of years. Studying Mars gives us a glimpse into our own planet's distant past, a view of what Earth may have looked like before life left its mark on stone. But imagine just for a moment if we really have found life. It would mean Mars remained habitable far longer than we thought. It would suggest that life can emerge wherever conditions allow, that biology is not a cosmic accident, but a cosmic inevitability. And it would force us to ask even deeper questions. Did life on Earth come from Mars? Or did both planets receive the same spark from interstellar space? If life arose twice, independently, then it might be everywhere. The Drake equation, used to estimate the number of civilizations in our galaxy, would suddenly explode with new possibilities. If 2 neighboring planets both hosted life, then maybe the universe is teeming with it. As astrobiologists like to say, in the universe, life can only exist in 0, 1,
or infinite places. We already know it's not 0. If it's 1, we're alone. But if it's 2, then it could be everywhere. And maybe, just maybe, when we finally find it, it will help us understand not only our origins, but our shared destiny among the stars.